Okay, so here's something different, right? Here's what we've done so far is we've said, okay, can you simplify something like this, square root of 50? Okay, now look, this is called a square root. Okay, it's what number multiplied by itself equals 50. Okay, and we would have to simplify. Now, this is called a cube root. This is called a fourth root. Okay, so here's the difference. I'm going to start the same, which is I'm going to factor. So like this would be 4 times 10, 5 times 2. I'm going to prime factor. I'm going to look. Okay, now see how this is a 3? See how that's a 3? So now, remember how when I was simplifying square roots, I would find a double like this? If this is a cube root, I'm looking for a triple, right? Why? Because, look, I'm going to separate it out and we can take a look at what this is. Okay, so anything that's a triple is going in its own house, right? Instead of a double, it's a triple. And then this is by itself. Okay, now, why? 2 times 2 is 4, times 2 is 8. Okay, now look, I'm sorry, there should be a 3 right here. This is the cube root of 8. The cube root of 8 means what number can I multiply? What number can I cube? What number can I take to the third power, right? What number to the third power equals 8? And it's 2, right? I just did it. 2 times 2 times 2 is 8. So the cube root of 8 is 2. So see how normally what we had was we had a double that would simplify into the number. Now, because there's a 3 right here, it's a triple. So this is 2 times the cube root of 5. That's my answer. Okay, now look at this one. This is a fourth root. So I'm going to start by factoring. Okay, and I think this is 16 times 3. This is 4 times 4. Okay, and you're going to see that I'm going to have 4 2's this time. Okay, which is good because look, I'm going to look for groups of 4. So same as simplifying square roots, except that we're looking for groups of, and look, 3 or 4. So I left this blank, but what it is it's this number right here. Whatever that number is, that's what I'm looking for. So in this case, what I have is I have a group of 4 2's. Okay, and there's like this is a fourth root. Okay, so this is a group of 4 2's that becomes 1 2. And then this is, the fourth root of 3. Okay, so it's like the same process, except it's just the matter of the groups we're looking for. Okay, here's a big number. I don't know the factor of 192. I don't. But what I do know is I'm like, well, it's even, so I know it's divisible by 2. And then let me just divide it by 2. And I can even do this. I can make a calculator if I need to. So let's see, this would be 2. Oh, brain fart. 96, and I don't know any factors of 96, but I know it's even, so I'm going to divide it by 2 again. And let's see, 48. I'm like, oh, that's also divisible by 2. I'm just going to keep going. Let's do 4 and 6 on this one. 3 and 2. Okay, oof, got a lot. So let's be careful. I have 1, 2, 3, 4, 5, 6 2's and a 3. Okay, now this time I'm looking for groups of 3. Okay, so group of 3, single. Okay, now let's say there was 2 3's. It wouldn't be a group of 3, right? It would be, you'd treat it just like a single, right? As if it's not a group of 3. If it's not a group of 3, then it doesn't get pulled out, right? So this becomes its own little house. This becomes its own little house. And this is the cube root of 3. So this becomes 2 times 2 times root 3, and so this becomes 4 times the cube root of 3. Okay, so kind of a long process, but not very different than what we did. It's just a matter of what am I looking for? I'm looking for groups of 3, or I'm looking for groups of 4.